Learning groups, and today we are going to continue to talk about speed lessons. All right, speed problems. So we are going to look at this question that's a little not easy, but we're going to use the ratio method, right, to see how we can solve it. So when do we use ratio method to solve speed problems? I think that's the question that many students will ask, right? Do I use ratio method for every time I see a speed problem? Not really. All right. So I'm going to show you when we use ratio method. So let's look at this question, and then we see what it's about. Now, you can see that Sally and Ken drove from A to B at a constant speed. So it means their speed never changes. And Ken started his journey 2 hours after Sally. So what does this mean? It means that Ken started his journey 2 hours later. So Sally started earlier. And Ken traveled faster than Sally by 40 kilometers per hour. So there's a concept here. So in this question, you have to understand who is faster. So if Ken is faster, then Sally is slower. And if Ken is faster, then Ken will travel longer distance. And how much longer? That will be 40 kilometers more in 1 hour. That is how much faster. And Ken overtook her in 3 hours. Overtook her means to catch up with her. So which means that both of them must have started from the same place, and both of them are now at another same place. So when Ken caught up with Sally, they are at another place, which is together. So find Sally's speed. And so once you understand the question, right, the next thing to know is how do you draw the model. So you may want to add up with your fingers and then draw out how your fingers move. So I'm going to show the distance line, which is A to B. So this is the distance line, and there's a dotted line to show where they start. So when you draw speed model, if you remember in the earlier lesson how you draw the basic of a speed model, you draw dashes to show where they start, and then who go first? So Sally go first. So if Sally go first, then I draw until here, because the question number says Sally has arrived, so I don't draw all the way to the end. Kenny started his journey 2 hours after, or 2 hours later, and he caught up. So when Kenny caught up with Sally, it means that they are now at the same place, right? So that's your model. So what's the next thing to do? The next thing to do is to recognize the different parts of the journey, and every part has a family. So for Sally, there's one part journey. So you have speed, distance, and time. And then for Kenny, there's also one part journey. So Kenny also has a family, speed, distance, and time. And then what do we do next? We plug the numbers from the question and put inside the model. So if you look at the question, Kenny started his journey 2 hours after Sally. So can we put the 2 hours inside? No, we can't, because that's not the time taken for Kenny to travel. So there are some numbers like what I mentioned last time that we cannot put inside, so we don't put. And Kenny traveled faster than Sally by 40 kilometers per hour. So can we put this inside the model? Also cannot put, because that's not the speed of Kenny. And Kenny overtook her in 3 hours. This one we can put. It means that Kenny took 3 hours to travel, right, to overtake her. Find Sally's speed, and your question mark is here. So after you have done all this, you realize that there are still many blanks, many missing numbers. So how to find the question mark when there are so many numbers are missing? So your job is to think of how to fill in the missing value. So if you look carefully, can you find, all right, anything? Can you put anything inside the model? Any missing number? For example, Kenny took 3 hours to travel, and if Kenny started the journey 2 hours after Sally, then Sally must have started 2 hours earlier than Kenny, right? So Sally must have started 2 hours earlier. That tells you that Sally must have taken 2 hours longer, because Sally started earlier, right? And then, so that will be 2 more hours. So 3 hours plus 2 hours, Sally must have taken 5 hours to travel. Yep. Okay, so once you have put that inside, you still find that there are many numbers there. Many numbers are missing. Alright, there are many missing values. So I see that there are two timings, right? There are 2 durations. And then that's when I think about whether can I use ratio method, because I can create something called the time ratio. So how do I create time ratio? So I have Sally is to Kenny, and time ratio will be what kind of ratio? Sally take 5 hours, which is 5 units of time. Kenny took 3 hours and 3 units of time. That's how you use ratio method. You look at the model and do you see two of the same variables? Do you see two of the same kind? And then you use that to create your ratio. And then speed. I can come up with the speed and the distance ratio. So what's the speed ratio? Now if Sally is taking longer time, and that will tell you that her speed is lower. So therefore that will be inversely proportional. So Sally will take 3 units, which is a slower speed, right? Slower speed than Kenny, who has a higher speed. So it's inversely proportional, or means the other way around. And then the distance will be the same as a speed ratio. So Sally will travel shorter distance, and Kenny will of course travel longer distance because he's faster. All right. So what do we do next? Now, since you have started with the time ratio, so we can't use that to solve it. So we will have to either use the speed or the distance ratio to continue to solve. So which ratio do we use to solve? Then you look at the question. Do you see that there is a 40 km per hour faster? So that tells you that I can look at the speed ratio, right? Because it's talking about speed, right? Kenny travel faster than Sally by 40 kilometers per hour. So I will not use the distance ratio, but I will look at the speed ratio because I can see that Kenny speed is 2 units faster than Sally. So Kenny has 2 units of speed faster. So which means that your Kenny is 2 units faster, and that is also 40, right? 40 km per hour. Right, so 2 unit is 40 km per hour. Then 1 unit will be 40 divided by 2, which is 20 kilometers per hour. So can I find the speed of Sally? Yes, I can, because Sally's speed is 3 units, so 20 times 3. So Sally must have a speed of 60 kilometers per hour. And I got my answer. So do I need to find the rest of the missing numbers? Do I need to find the distance, the speed, and the distance here? Well, you don't need to, because you already got the answer ready. So you can just stop. Alright, stop solving and then just put down the answer at 60 kilometers per hour, which is the speed of Sally. So what is the lesson here? Now the lesson here is, how do you know whether you need to use ratio method? You draw the model, right? You draw the model and then you find that there are many missing numbers, right? Many blanks. And then you see that there are 2 kinds of timing, 2 kinds of time, right? You know how long Sally took. You also know how long Kenny took. And then you can use that as a ratio. And you use that as a time ratio, and use a time ratio to create your distance and your speed ratio. And then after that, choose the right ratio, right, to continue solving. So that is when you use ratio method, right? So of course there could be other ways to solve it, yeah, but otherwise ratio is one of the methods that you want to consider when you're doing harder speed problems. Alright, so that's how we do these speed problems, and continue to stay tuned, because we will continue to look at other speed problems so that you have a better understanding of how to draw the model and how to use the model to solve. Alright, okay, so see you in our next lesson.